Okay, so we're going to start out looking at parallel. What does parallel mean? As I told you, it means the same slope. So let's go ahead and do an example. Y equals 5x plus 4. So if I wanted to make an equation of a line that was parallel to y equals 5x plus 4, the only thing I have to do is make sure that my slope is 5. So I'm going to go ahead and put 1 in there. Y equals 5x minus 50. So as you can see, the two slopes are the same. So I know these two lines are parallel. Now, one thing that I need to remind you of is that when you're talking about parallel lines, if they had the same slope and they crossed at the same place, they would be the same line. So only on parallel lines, you need to make sure that the intercepts are different. Because if I said y equals 5x plus 4 and y equals 5x plus 4, those would be the same lines. So as you can see, the two slopes have to be the same, but the intercepts must be different. Okay, so let's let you try one. I want you to write the equation of a line that is parallel to this line right here. Let's go ahead and pause it. Okay, so I had to make sure that my slopes were the same and these two were different. If I'd have put minus pi, they would have been the same line. But anything other than minus pi, I could put plus pi, I could put 75, I could put any number right here. As long as these two things are different, and these two things are the same, your two slopes are the same, these lines are indeed parallel. And that's all there is to parallel lines, same slope. So let's go ahead and look at perpendicular. Oh, just showing you those are different. Okay, let's look at perpendicular. Okay, so on perpendicular lines, I told you that those are the opposite reciprocal. Opposite reciprocal. So let's look at an example. I need the opposite reciprocal of this slope right here. I need the opposite reciprocal of this. That means that I need to flip 3 over 5 upside down and it becomes 5 over 3. And since this is a negative, then the one that I'm going to have is going to be a positive. So that's it. That's all there is to it. I have to make sure that this is 5/3. Okay. And that should be 5 over 3. Make sure it looks like a 3. There we go. That should be 5/3 because that is flipped upside down and a different sign. And this doesn't matter. This right here, this could be +2. It could be plus anything. It doesn't matter. I'm going to put, I don't know, -40. It just doesn't matter what it is. Okay. As long as you flip the slope upside down and change the sign. And there's the bell. Okay. So there you go. As you can see, I flipped them upside down from each other and changed the sign. That was it. And then these two just have, they can be the same or different. It doesn't matter. They can both cross at the y-axis. That's only on perpendicular. Okay, so let's let you do an example. Y equals 7x plus 9. Go ahead and make an equation of a line that is perpendicular to y equals 7x plus 9. And go ahead and pause the video. Okay, so it wouldn't matter what I did as long as I took this 7x right here. I took 7 and I have to flip it upside down. Well, how do you flip 7 upside down? Well, first it has to look like a fraction, right? And 7 over 1 and 7 are the same thing. 7 divided by 1 is 7, right? So when I flip it upside down, it becomes 1 over 7. And since this is a positive, this now becomes a negative. So -1/7 is what my new slope would be, or the slope of the line that's parallel. And this could be anything. I'll just go ahead and leave it the same thing. It doesn't matter. It could be anything on perpendicular. So there you go. Flip it upside down and change the sign, the opposite reciprocal. Okay, so there it is. I flipped it upside down and changed the sign, and here these are the same. It doesn't matter. These both cross the same, but this could be something different. It just really doesn't matter. Okay, the last possibility that you might run into is if they're the same line. Okay, that means they cross everywhere. And here's an example. So I'm going to write another line that's the exact same line as this. And it's actually very simple to do. All I'm going to do is I'm just going to multiply every one of these terms, the y, the 3x, and the 2, all by the same number. I'm going to pick 6. So I'm going to take everything in here times 6. So y times 6 is 6y. 3 times 6 is 18. And right here, I want to point this out because I saw this a lot back when we were doing systems of equations. People would say that 6y equals 18x plus 2. is the same line. It's not. You have to multiply all three terms, all of them, by whatever numbers you're multiplying. So positive 2 times 6 is 12. So there's your example. I promise you, these are both, if you plotted these, they would both be on the same line. If you did an XY table on both these, they both have to be on the same line. And if this will not simplify, but this one, I divide everything by 6. If I divided everything by 6, it would be the same line. These are the same line. They both simplify down to the same equation. All right, so here's your example. 3y equals 4x plus 5. Just make any line that is the same line as that one. That doesn't look like that, okay? All right, go ahead and pause. All right, so I picked 3. I just multiplied everything by 3, okay? I just multiplied everything by 3. 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So these are both the same line. And they would both simplify down to the same thing. This is technically not simplifiable right here because there's nothing that goes into 3, 4, and 5. But if I did simplify it down to, and it's not really simplifying, but if I brought this down to a y equals mx plus b, what that would look like is this. I've got 3y divided by 3 is y. That would be also divided by 3, so 4/3 x. And this would be 5/3. And that's also what this one would simplify down to. They both simplify down to y equals 4/3 x plus 5/3 if you meant to get them down to slope-intercept. Anyway, that's some information on how to do parallel and perpendicular. If you have any questions, just let me know. Thank you very much.